Hello, students!
So how do aqueous chemical reactions behave? How do electrolytes behave when they're in these aqueous chemical reactions? Let's talk about an example. If you mix two aqueous solutions together, perhaps you mix potassium iodide with lead nitrate. Mix those two together. Well, we know this is a double replacement reaction, so the lead is going to pair with the iodide, and the potassium is going to pair with the nitrate. So nothing really happens with the potassium pairs with the nitrate, but PbI2 iodide with lead is insoluble, so it's going to form a precipitate. But in reality, if we have these aqueous solutions, we've already talked about this, if you add Ki to water, it actually looks like this, because the ions are going to break down. Aqueous means the salt is broken down in water. So we see, and remember this coefficient needs to be distributed to the whole thing, but we have 2K plus aqueous, 2I minus aqueous, we have 1 lead, but we make sure we show the charge of 2 plus, we have 2 NO3 minuses, that's how they balance out, and that forms PbI2, because this is not soluble, it's not going to break down, it's not a strong electrolyte. So we have PbI2, it's a solid, and we have 2 potassium and 2 nitrate again. So that's great and wonderful, right? We've got that's called an ionic equation because it's broken down into ions. However, let's think about something. What is a spectator? So if you're at your favorite sporting event, perhaps you like to see the Minnesota Wild or the Minnesota Vikings play a game. You'd be a spectator, right? Are you actually playing a part in the game? No, you're not going to see them clobber the Bears or the Hawks. I mean, that's going to happen, but you're not going to see it. So you're just a spectator. So your role is just to kind of be there while the actual action is going on. So let's talk complete ionic equation again. We just saw it. We had 2 potassiums, 2 iodides, Pb2 plus, remember to show the charges. If we're aqueous, we mean we're in our ionic form with our charges. 2 nitrates, that's all our reactants. We added these things together. And again, we got our PbI2, that's the solid, because it's the actual reaction. It is insoluble, so that's actually that change. And then we've got our potassiums, and we have our nitrates. Well, we can write a net ionic equation. Remember net gain. If I spent $10 on a shirt and then I sold that shirt for $15, I had a net profit, a net gain of $5. Well, we have a net ionic equation here where we remove the spectator ions. Let's use red. So spectator ions, again, whatever is going to be the same doesn't change. You know, I'm a spectator, I'm not going to change in the stands. I might enjoy myself, but I don't win the game. I'm not in on the action. So potassium, we see potassium the same at the beginning and the same at the end. Iodide, well, it's going to do something, right? That iodide becomes here. It starts aqueous and it ends up solid. Well, how about lead? Starts aqueous, ends up solid. It changed too. Well, how about nitrate? Nitrate, aqueous, 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 aqueous. It's exactly the same. We can cross that guy out too. These are spectator ions. They're just along for the ride. And then our net ionic equation is just taking what's left over, the things that actually participated in the equation, they actually participated in making the precipitate, and they are our, that is our equation. So we have what we started with, and our net equation, because we crossed all those things out, is 2 iodides, Pb2 plus aqueous, and that makes PbI2. And even though these are not in that order here, because Pb is our cation, it comes first, and we see this actually should have aqueous here. 2 iodide aqueous plus Pb2 plus aqueous yields PbI2 solid. That is our net ionic equation. Let's do another example. So solutions of silver nitrate and zinc chloride are combined together and react. Let's write that out. Silver has a 1 plus charge, and nitrate has a 1 plus charge. So that's how we're going to start out. That is aqueous, because they're in solution. We add that to zinc chloride. Zinc has a 2 plus charge. Chloride has a 1 minus charge, so we have 2 of those. Again, this is aqueous. Great, aqueous. Now, this is going to be a double replacement reaction, so we're going to flip-flop these guys. So now we have Ag, again with the 1 plus, and Cl with the 1 plus. And we know we're going to flip these two, so we're going to be Zn NO3. However, that Zn again still has the 2 plus charge, nitrate still has the 1 minus charge. Check your solubility chart if you're not sure. So that's going to be a 2. Now, we know these things are going to switch, so now let's check their states. If we look at the solubility rules, we see Rule 4 about chlorides says that with silver, it is going to be insoluble, so we're going to write an S here. How about zinc nitrate, though? Nitrates, second rule, are generally soluble, so this is going to be NaQ. Then pretend that's noticeable. So now, this is our molecular equation. Molecular. Okay. Oh, we didn't even balance it yet, right? Because we've got 1 nitrate here, 2 nitrates here, so let's write it out. I'll write it small. Ag 1 1 NO3. We've got 2 1. Remember, it did tell us to do the balance. Zn 1 1. And our Cl's 2 1. So let's balance out the nitrate first. Put a 2 here. That's going to give us a 2. And nitrates, that gives us a 2. These are balanced. However, the Ag's not, so we're going to put a 2 over here. We put a 2 over there, gives us 2 here. And our chloride is now at 2. Now we're balanced. All right. Now, that is our balanced molecular equation. Let's do the complete ionic. I'm going to shorten it to CI for short. CI. So, let's break this down. It's aqueous. So we know we have Ag plus AQ. We have nitrate. NO3 minus AQ. We have zinc. However, zinc's a 2 plus, which we know from our ion charges sheet, or right here, we know chloride's got the 1 minus, so we need 2 of those. Again, AQ plus 2 chloride. In fact, there's a 2 out here. I need to include that 2 here. 2, 2. This 2 comes out front in the complete ionic. 2 Cl becomes a coefficient. Now we're going to break this down. However, we have AgCl and it's a solid. Is it going to break down? No. No, it is not. Or we still need 2 of them. 2 AgCl solid. Don't forget your states. It's a Q. Plus, this is aqueous, so it will break down. So again, Zn2 plus aqueous plus NO3. 2 of them. And it's aqueous. So in writing it down, we break it apart. If it's aqueous, we make sure we include all the coefficients necessary. We make sure to include all the charges, and we make sure to include all the states. But let's get now our net ionic equation, because we've got some spectators. Because let's see here, our 2 Ag plus, okay, that is going to change. It starts aqueous, it ends up solid, it's good. How about NO3 minus? We've got 2 NO3 minus aqueous, we've got 2 NO3 minus aqueous. I'm even going to change the color. Nah, these guys are spectators, they're not helping. We've got Zn2 plus aqueous, we've got Zn2 plus aqueous, spectator, sitting around watching. And then finally we have 2 Cl minus aqueous. Well, Cl is going to change state. It's not aqueous anymore, it's now solid. So our final net ionic equation is 2 Ag plus, starts aqueous, we add that to what's left over, 2 Cl minuses, aqueous, and that yields 2 Ag Cl, which is our solid. Different states, different state, different state, different state. And that is our net ionic equation. 2Ag plus Aq plus 2Cl minus Aq yields 2AgClS. All right, well, we have one more important example. And as a little bit of a hint, it's going to go much faster. So let's write it out. Solutions of magnesium nitrate and sodium chloride are combined. Write the balanced reaction, complete ionic, and net ionic reaction. So let's start out with magnesium nitrate. We've got Mg, and this is a 2 plus charge, and we're dealing with nitrates. So it's NO3. Got 2 of these guys. Balance out the 2 plus charge. Again, we look, nitrates are insoluble. So we've got AQ, and we see that it says solutions. Sodium chloride, you guys know that one by now. NaCl, again, aqueous because it's in solution. We know it's a strong electrolyte. It's group 1A. So now let's switch. We've got MgCl2. This is aqueous. Well, let's see. And then NaNO3. Okay, aqueous. Now, I buried the lead a little bit, but let's see here. MgCl2, when we look at chlorides, there is no exception that said magnesium is going to be insoluble. Sodium is still a group 1A, and nitrates are generally soluble. So they're all soluble. So in reality, we made no precipitate. We made no actual reaction here. So you can just write no reaction. And there is no ionic equation, and there is no net ionic reaction because there is no reaction. And I hope that's helpful.